Hello, this is Chris, ZL1CVD. I've been just taking a bit of a break here. I've been soldering hard at it all week, working on new products and what have you. But anyway, I wanted to play with some military radios. And these are the PRC-2200. They're from the early 2000s, late 90s. Quite a luggable radio. They're probably, I don't know, probably about 8 kgs with battery, maybe 9 kgs, but as you can see they're quite big. I did another video with this little transceiver here. I'll just show you the difference in size of the two transceivers. So this was used by the German army, and this one here I believe is used in Brazil, the Brazilian army and the South African military. So both these radios support encryption and both of them support frequency hopping. We've shown you a video on this one here of how the frequency hopping is working. I haven't worked out how to get encryption going on it yet though. But I have worked out today how to get encryption going on the PRC-2200. So they're really complicated radios to use, and so I've got my little cheat sheet on the side here which gives me some basic functions. Anyway, what I wanted to do was to get secure communications working between this transceiver and this transceiver, and I hadn't been able to get it going. I went onto the PRC-2200 user groups, and I read a lot of information about this, some great data on there, and what I came up with is this spreadsheet here, and this is a key generator which gives you the encryption keys. They've got to be entered in a certain way on the radio, so there's a couple of tables here. You can either put your own keys in this one, or you can have the spreadsheet generate it's a random set of keys on this one, and that shows you down here how to enter the keys into the radio, which I've done, and it still wouldn't work, which was a bit annoying. But anyway, pondered on, and I found that not only does it have secure encryption, but it has secure encryption between units. So I guess that's between, so if a commander wanted to talk to a particular unit, he could just, without the other units hearing, he can set it up so it will do that. And what I'd failed to do was set it up so that the two radios were so that this one or that one knew that it was calling each other. So now what I've done is I've set it so that this radio will talk to all, and this radio will talk to all. So anybody on the same frequency with the same encryption codes, it will hear. So what does this sound like? Let's just go over here. We've got a FTDX10 here, and I don't know if you can hear a bit of garbage going on in the background there. Right, now this here is a tone that's being sent that synchronizes everything, and below that, in this area here that you saw, was my voice, the encryption part of my voice. We'll turn that up a bit, and it sounds like this. Testing 1, 2, 3, 4, 5. So as you can see, you would never be able to understand that if you didn't have the correct transceivers and the codes and so forth to do it. Okay, so don't worry, I'm not really, whilst it is over air, I'm actually transmitting into dummy loads. There's a cable going out, power meter, dummy load on the back, and the other one is a power meter, dummy load, and a lead going into the other transceiver. So let's listen now onto how the decryption of it works. So hello, testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a test. And you can see there's a delay. There's an absolute delay from one transceiver to the other. And that's because this transceiver has got both of them have got what they call a vocoder in them. So this one is encoding the speech and this one is decoding the speech. So there's a delay between that. But even so, when you use these transceivers, there's a noticeable delay. Even when it's in clear voice speech, when you're using it just on standard SSB, you do notice the voice difference. And my cat wants to say hello. She's just woken up. Anyway, so that was a quick rundown on what just to show you how the scrambled speech works. These transceivers also support frequency hopping, whereby you load in a range of HF frequencies, and they will hop between those frequencies. They also support, I believe, and I haven't tried it yet, is a thing called ALE, which is automatic link establishment. I believe that these radios can do it, but there are different. You can download off the group's IO website user group different firmware for them. I've programmed a couple of flash EPROMs in these, or a flash EPROM for each one of them, with a revision F firmware, which I believe supports the ALE, but I'm not quite sure. Anyway, ALE, automatic link establishment, is where you have a group of or multiple HF frequencies across a wide range. So say you could have one for 80 meters, 40, 20, 10, 15, 12, so on, 17. You load those spot frequencies into it, and the radio will jump over to each one of those frequencies until it finds a communication with the other transceiver. So as it's sort of the name says, automatic link establishment, that's exactly what it tries to do across a range of frequencies on the HF band. Now amateurs actually do use ALE, and you might want to look that up if you want to learn a bit more about some of the propagation methods that you can, or not propagation methods, some of the communication methods you can use on HF with various transceivers. Anyway, that's enough waffle for now. I'll let you go. I only wanted it to be a short video, and thanks for watching, and please subscribe. Cheers.